Okay, we're carrying on here. What we've done is we added an out variable in the vertex shader. It's calculated right here. Frag position equals vector 3, the model, times vector 4 position. Okay, and that's described right here in the tutorial. Right here. We can accomplish this by multiplying the vertex position with the model matrix only to transform it to world space coordinates. So we just want the position of the model. That'll give you the fragment position. And the corresponding input variable in the fragment shader in vector 3 fragment position. And then we're going to do calculations on that. Now that all the required variables are set, we can start with the lighting calculations in the fragment shader. Okay, so the first thing we need to calculate is the direction vector between the light source and the fragment's position. Okay, we mentioned that the light's direction vector is the difference vector between the light's position vector and the fragment's position vectors. You might remember from the transformation tutorial we can calculate the difference by subtracting both vectors. We also want to make sure all the relevant vectors end up as unit vectors, so we normalize both the normal and the resulting direction vector. Vector 3, we're going to call this norm, as if we just talked into the bar and chairs. Norm. Normalize. Normal. Okay. So that's done. Vector 3 light dir equals normal. Normalize light position minus frag position. And are those, see, light position minus frag position. Okay, light position is a constant that we're sending in, and the fragment position is being sent through the vertex shader. Okay, so it says when calculating lighting, we usually do not care about the magnitude of a vector or the position. We only care about the direction. Because we only care about the direction, almost all calculations are done with unit vectors, since it simplifies most calculations like the dot product. So, when doing lighting calculations, make sure you always normalize the relevant vectors to ensure they're actual unit vectors. Forgetting to normalize a vector is a popular mistake. Okay, so that goes along with pizza, which is a popular food. Next, we want to calculate the actual... go away. We want to calculate the actual diffuse impact the light has on the current fragment by taking the dot product of the norm and light dir vector. The resulting value is then multiplied with the light's color to get the diffuse component, resulting in a darker diffuse component the greater the angle is between both vectors. That's a nice little description. Okay, so here we go. Float diff equals max dot norm light dir. Okay, I can deal with that. Float diff equals the maximum between the dot norm comma light dir, okay, and 0. So whatever's greater, 0 or the dot of norm and light dir. That was tough. This is very difficult. I'm wiping the sweat off my brow as we go, so stay with me. Okay, and then the diffuse is actually equal to the difference times the light color, which in this case, hold on. Vector 3, I'm so confused right here now. Okay, so this is the final. Light color, because the light color is not, is it? What am I thinking? I don't have the light color in there, do I? No. No, you don't. Shh. So vector 3, I don't think this is going to work right. I have to figure this out. I don't want to figure anything else out tonight. I'm already pooped. Sorry, I didn't mean to say the P word. Diffuse equals diff times light color. That's not going to work because light color is not... I can tell I'm just tired. It's 8 o'clock. My bedtime's 9:30. I'm tired. Oh, I don't want to do this. I just can't think. I just cannot think. I swear I've not been smoking anything and I can't think. Maybe that's what I need to do. Go get some or drink something. Diffuse. Well, here, ambient, strength, texture. Now that we have both an ambient and a diffuse component, we add both colors to each other and then multiply the result with the color of the object to get the resulting fragment's output color. Did we already decide on the light color? Is that... because I don't know what's going on right now. I'm so confused. Yeah, this may not get published. I may not put this video out there because I think it's all... I don't think this is going to work. Object color. Or no, I'm not even looking at the right calculation right now. Light color. That was way back in the beginning. Oh, gosh. What time are we going on? Oh, it's only 6 minutes. Okay, all right. Stay tuned here. Light color. Here, light color. We're literally looking for a light color in a haystack here. Here, light color. Or wait. Light color? No, it's not in the... Alright, let's just skip down here. Let's go into here and see if we can find the light color. Yeah, when in doubt, look in the source. Okay, light color, light position. I don't think that... How does it get light color? I'm getting dizzy. Clear color, light color. Oh, so it does send the light color just white. Okay. It sends the light color to the shader with a uniform. Well, that's tricky. Didn't mention that to me. And there's an object color, which we're just using the texture. So, okay, I can deal with that. It's all white. It's a vector 3 of 1. Okay, you don't have to... Here. No. Yes, wait. Where are we? Oh, we're right here. Great. Okay, go back to the fragment shader. Pay attention. Pay attention to what you're doing. No, I refuse. So diffuse equals diff times vector 3, 1. There. Okay. Diffuse. So we have diffuse. Assuming the light color is white. Okay. So now that we have both the ambient and diffuse, we add both colors to each other, ambient plus diffuse. So the result, and then your final color is going to be the result. Oh, okay. All right, hold on. I'm so nervous doing this. I'm just super nervous. Okay, so vector. Ambient's a vector 4. Diffuse is a vector 3. Alright, let's just make diffuse a vector 4 because I want to. This is going to be a vector 4 diff, comma, 1, and then this will just be vector 4. I'm not sure that's going to work because I hate working in these shaders. Calm down. Breathe through the mouth. I wonder if other programmers just get as out of control like I do. Times what? Times what? Times, oh, what? Really? Are we supposed to do that? I don't know. Mom didn't say. add that again? We're supposed to add that again? Color equals result. I am incredibly skeptical. If your application compiled, what? Compiled? No, screwed it up. Fragment shader failed to compile with the following errors. Error 16, error 016, not enough data provided for construction constructor. One compilation error. Link failed. Wow. So it's the fragment shader. I knew it. I got this thing all effed up. Oh, normal, frag position, color, light position. Normalize, oh normal, light dirt, normalize light position, minus frag position, float diff equals max, dot, norm, comma. oh wait, no, that's right, norm, comma, light dirt, 0. Diffuse equals vector 4, diff. Oh, wait a minute. Just go like that. I don't know. That might have been it. I don't know. Let's see. Holy Moses. Wait, is it? What's it doing though? I don't know. Is this working? How could this possibly be working? It looks like something. Alright, well. We're going to revisit this tomorrow. We're going to call this the end of Diffuse because I am so tired of diffuse calculations, and what I need is a whiteboard and to sit down with geometry and figure this out because, wow. Okay, well, it kind of looks lit on we're just going to call this random diffuse lighting. I know, okay, there's a mistake here somewhere. The challenge is to find it. We will find it. It's true. All right, stay tuned. Be sure to like and subscribe. Thank you for watching very much, for your attention tonight. It's been so fun. Hasn't it been fun? Yes, you get into the world of a crazy programmer and do his mind and just be like, I don't want to become that. No, actually, I just kind of let loose and just kind of go fancy free with my programming style here, and I just kind of speak from the top of my head and just kind of relieve so much stress from the workday. It's pathetic. So pay no attention to anything I've said. It's kind of all in fun. Anyways, and thank you for watching.